Hello, everybody. This is Mr. McNair, and this is the final review coverage for the Chapter 7 portion of the final exam review packet that I gave to you guys. Here's the answers for the problems, all right, 30 through 40. All right, you can pause the video if you need to. All right, let's go over some select problems. Number 31, find the GCF of each pair of monomials. GCF, once again, meaning the greatest common factor. So when you're doing that, first thing that you want to look at is the coefficients on the numbers 15 here and 9. What's the biggest number that divides evenly out of both 15 and 9? Well, that number is 3. Okay, so that's the numeric part. And then between n to the fifth and n to the fourth, you want to be able to take the same amount of variables out of both of those, but you want to take the most because it's the greatest common factor. So what's the most variables you can take out of n to the fifth and n to the fourth? You can take out 4 of them. Okay, once again, I've explained this in class a few times. I like to think of it as a person. You're trying to, let's say you're a thief, right? And once again, I don't promote stealing, but you want to steal from 2 people. This person here has $5. This person here has $4. However, you want to steal the most that you can from both of these, but because you're a particular thief, you have to steal the same amount. Well, because this person right here only has $4, that means you can only take $4 from each of them. Okay? Because you want to steal the same amount, but you want to steal the greatest amount possible. All right? So that's how, once again, we got the n to the fourth. All right? Great. Let's move on. Factor each polynomial. First thing that you're going to do when factoring the polynomial is take out the GCF. Okay, so the GCF between 16y squared and 12y is 4y. Put that there on the outside. In the first position here, we're going to divide out that 4y. So 16 divided by 4 is 4. Y squared divided by y is y. And then in the last position, 12 divided by 4 is 3. You only had one y, and you took it out. So that's it. Okay, and there we go. We factored it. All right, this problem. First thing you do in this problem is look and see if there's a GCF that comes out of all 3 of those terms. And there isn't. Okay, so here you see that A is 1, B is 7, and C is negative 18. When A is 1, the process that you go through is to find what 2 numbers. The process you go through when you factor, I'm sorry. The process you go through when you factor is find what 2 numbers multiply to C and at the same time add to B. They have to multiply to C and at the same time add to B. Okay? So what numbers multiply to negative 18 and at the same time add to positive 7? Well, those 2 numbers are positive 9, positive 9 and negative 2. So that's x plus 9 times x minus 2. All right, because once again, positive 9 times negative 2 equals negative 18, and positive 9 plus negative 2 equals positive 7. Okay, and there you go. That's your answer. Now, once again, let me say this. You can FOIL this, and you should get that. That's a good way to check your answer. Okay. This problem here, once again, look and see if there's a GCF that comes out of all 3 of those terms. And there isn't. So here A is 4, B is negative 9, and C is negative 9. Alright? Now, when A is not equal to 1, like A is not 1 here, I taught you guys 2 methods to factor this. The first method I taught you was the guess and check. Okay? However, most of you seem to be you like more the AC method. In the AC method, the first thing you do is multiply the A and C together. Okay, so that here equals negative 36. After you have that, you find what numbers multiply together to give you this negative 36, but at the same time, add together to give you negative 9. Okay, so what numbers multiply to negative 36 and at the same time add to negative 9? Well, that's negative 12 and positive 3. After you do that, what you're going to do is you're going to take these numbers and you're going to replace the b, that negative 9x. So this is what we're going to do. We have 4x squared, we're just bringing that right down. Okay? And then instead of negative 9x, we're going to put these negative 12x, and positive 3x. And then we're just going to bring down that negative 9 as well. Okay, now you have four terms, and you can factor it by grouping. Group the first two, group the last two. What's the GCF here of the first set? Well, that would be 4x. Left on the inside will be x minus 3. And then what's the GCF of the second set of parentheses? That would be a positive 3. Left again is x minus 3. Now notice, these two parentheses are the same. They need to be. If they're not, you've done something wrong. So now you factor out that common GCF, or that common binomial, which was x minus 3. Okay, that's what we just factored out, leaving us with 4x plus 3 to go in the other parentheses. All right, and there we go. That's our answer. Once again, when you FOIL that, you should get that. All right, moving on. This one. You already have four terms in this problem. Once again, when you have four terms, you factor by grouping. So group the first two, group the last two. What's the GCF of this first set? Well, that would be p cubed, leaving you on the inside with 7p minus 2. What's the GCF of this second set? Well, that would be a positive 9, leaving you once again with 7p minus 2. These two sets of parentheses should be the same. If they're not, you've done something wrong. All right, so let's factor out that common binomial, 7p minus 2, and leaving us with p cubed plus 9. Okay. You always want to check these problems and just make sure you're done. Check and make sure that you don't have a difference of two squares or anything going on, or another GCF that could be factored out. All right, here we go. This problem, factor 2p to the 8th minus 2. I like this problem. This is one of my favorites. So first thing, is there a GCF we could factor out of those two? Yes, we can take out a 2, leaving us with p to the 8th minus 1. Now this pattern right here is called the difference of two squares. The difference of two squares. Remember, it's a difference, so it has to be subtraction. All right, in the difference of two squares pattern, you set up two parentheses. To factor it, you set up two sets of parentheses. In the first positions here, we put the square root of the first one. So the square root of p to the 8th, that's p to the 4th. So we're going to put p to the 4th here. All right. In the next set of parentheses, in the next position, we're going to put the square root of the second one. The square root of 1, well, that's 1. So that's going to go here. One of these will be a plus, one of them will be a minus, and then we'll just drop down our 2. Now notice again, though, we have another difference of two squares. It's a difference of two squares. That's why this one, we can't do anything with that. That's a sum. Okay? So, again, we're going to do our same process. We're going to put down two sets of parentheses. In the first position, we put the square root of the first value. The square root of p to the 4th is p squared, and the square root of 1 is 1. 1 is a plus, 1 is a minus. And then we drop everything down. All right? But then again, we have another difference of two squares. Okay? So, we'll set up another set of parentheses. Two sets of parentheses, I should say. Put the square root of p squared in the first position. Square root of p squared is p. Put the square root of 1 in the next position. Square root of 1 is 1. 1 becomes a plus, 1 becomes a minus, and then we're going to drop down everything else. All right, and there we go. We're done. We don't have anything else that we can do with that problem. Okay. Lastly, number 40. Joe and Jim are responsible for the centerpieces on the buffet tables at the school dance. They have 6 dozen carnations, 80 lilies, and 64 rosebuds. Each centerpiece must have the same number of flowers, but can only contain one type of flower. How many centerpieces can be made if they put the greatest number of flowers in each centerpiece? All right, first thing I would deal with is find out how many flowers we're working with here. How many carnations do we have? Well, we have 6 dozen, which means that there are actually 72 carnations, right? Then we have 80 lilies and 64 rosebuds. Now, they're doing centerpieces, and you want the same number of flowers in each centerpiece. But you also want the greatest number in each centerpiece. So the first thing that we need to do is find out, if we're using all these flowers, we need to find out what is the greatest number that divides evenly into all the number of flowers we have. Well, the greatest number that divides evenly into all of those is 8. 8 is the GCF. All right. Now that we know that 8 is the GCF, we can find out how many of each centerpiece we can deal with. For example, how many carnation centerpieces will we have if we put 8 carnations in each centerpiece? Well, we'll have 9 of those because 8 goes into 8 goes into 72 9 times. How many lily centerpieces will we have if we have 8 in each centerpiece? We'll have 10 of those. And then how many rosebud centerpieces will we have if we have 8 going into 64? Well, that'll be 8. So we add those up, 9 plus 10 plus 8, and therefore we will have 27 centerpieces. Okay, great. Hopefully this was helpful to you, and good luck studying for your exam.